having 13 plus years of experience in Java, GTE, and Hadoop technologies. So out of that, more than 10 years of experience in Java, GTE, and for the past 3 years, I've been with the Hadoop framework guys. So I don't want to reveal the company name. I'm playing a role as a technical architect, and especially in that company, this is my 10th years. From past 10 years, I'm been with the same organization, different roles and different domains. So currently, I'm working for the banking domain for like one of the leading bank in US. Um, I'm handling two projects, one Java project and one is like Hadoop project. Okay. Coming to teaching point of view, I think like more than 2 years of experience in Hadoop teaching. Okay, this is what like just my brief introduction. Coming to this course, what we are going to be talking about today's session. So the thing is, what we are going to be covering is the basic information about Hadoop, why we need to have Hadoop, what are the problems in our traditional system, and the basic high-level architecture about our Hadoop and the course, how it is goes, then the general question and answers. So the question and answers, like in the last, like why we are keeping this, those are like general queries, not related to technical things. Like suppose if I am saying something in that topic, if you have any queries, you need not to wait until end of the session. You can unmute and you can talk to me directly. You can raise your voice. Okay, then we'll start it, guys. So I think first of all, I think the basic definition of Hadoop, everybody knows it. It is for like big data, like maintaining and processing huge volume of the data. So before discussing about that, why we can have huge amount of the data nowadays? Like I think before like 5 years back, nobody is going to be talking about Hadoop. So and from the past 2 to 3 years, I think it is more huge demand in this Hadoop. Why? Because this is the general statistics we are going to be discussing here. Throughout the world, like if you have 100% of the data, out of this 100% of the data, more than 90% of the data gets generated from the past 3 to 4 years. The legacy data we have only from like I think the computer generation gets started around 1980s. From there, then onwards, I think we have very less amount of the data. That drastically the data is increasing from the past 3 to 4 years. Why? Because if you see the second slide here, second image here, these are the information about not for like 1 month or 1 year statistics here. This is only for 60 seconds, means 1 minute. So in a minute, nearly 1 lakh tweets, nearly 7 lakhs of Facebook updates, and 11 millions of messages and 7 lakhs of searchings and all. These are the statistics here. Within minute, these many updates are going to be happening. So they are going to be logging in. So like this, we can have huge volume of the data. And here, if you see, like moreover, like social media things like Twitter, Facebook, mailing, searching, and all those things, right? Down the line, we are going to be talking about all the applications also. In all the applications, all the domains, day by day, the data is increasing. The number of users are increasing. Their usage is increasing. So if you want to be discuss more in detail, I think we'll go with like very simple example. Might be everybody might be the same experience, I guess. I am going to be explaining my scenario here. I have a desktop when I was doing my MCA around 2002. The configuration was very, I think, minimal, but at that time it was high-end configuration, guys. The hard disk is 40 GB and the RAM is 256 MB. So this was my mission at the time of my graduation, MCA. And now, the year 2016, right, I have a laptop, now whatever the laptop I'm using to take the classes and all. The hard disk configuration is 1 TB and the RAM is 8 GB, guys. So here, if you observe, the person is same. Within the span of 15 years, the person's storage capacity get increased from 40 GB to 1 TB. Do you think still I am using 40 GB of data out of 1 TB, guys? No, it is like more than 50% of the data I have used data. Let me show you if you want. I think not only for me, guys, like for everyone. See, I have 4 drives. all the 4 drives might be more than 50% filled up here. Why? Because the utilization is more nowadays. Person is same, but here out of 40 GB might be 20 to 30 GB we might be using it at that time. But now more than 600 to 700 GB we are using it. So proportionately, when the data is increasing, the RAM also definitely we need to be increasing, right? So that's why 256 MB to 8 GB RAM we are using it. Why? What might be the reason is? What is the main reason for increasing the storage capacity from 40 GB to 1 TB as a individual statistics? We'll talk about it. Like later on, we'll talk about application point of view. The main reason is internet case. Only because of the internet we have huge volume of the data. If there is no internet, it is very tough to generate the data again. So what is the problem with this internet? Why we can have huge volume of the data by using internet is, by using internet we are going to be downloading so many images, so many documents, so many images and audios and videos. 99% if you compare with your data, whatever you have in your laptop or desktop, these kind of the data only. So you are going to be getting it like through internet only. Either might be cloud or like anywhere else. Previously, if you want to store something in your hard disk, we used to be like in olden days floppies, then CDs, then DVDs, then pen drives, then external hard disk. Now everything is through cloud. I am going to be uploading it to somewhere else. You are going to download it from there itself only through internet. That's it. So this is the main reason. So as an individual person, why the storage capacity get increased for that particular person means this is the main reason, guys. The same thing if you are talking about an application point of view now. So this is the main thing we are going to be talking about, right? Let us talk about the social media, any mailing system like Gmail. I think Gmail is started around 2004. When they started the mailing server, I think they used to provide 1 GB for each user. So I think here out of like 5 to 6 people here, how many people might be having Gmail account in 2004? Before 2005, I think very less people. But the same thing, if I'm asking in a different way, how many of you are having now less than 2 Gmail accounts? Again, you will not get any response. Because nowadays everybody is going to be having 2 to 4 accounts on an average. For like your personal things, one like suppose you are putting your resume, for that you are creating one, you are going to be having one group, like your college days and all, like you want to communicate, you are going to be making one more mail ID and all. So minimum accounts people are maintaining it. So the number of users are more, and proportionately, can you guess how much data they are going to be providing in your mailbox? Suppose if I am opening a Gmail account now, how much storage capacity I am going to be getting in the Gmail server? 15 GB. You can store up to 15 GB data. It might be documents or anything. But in olden days, like around 2004 and 5, 1 GB only. So at that time, 1 GB is very, very huge. Because I have mailings, means I have a mail account in around 99, approximately 2000, under graduation. So I used to have like a Hotmail and Yahoo. Once Gmail is launched, all people are like migrated at a time. Why? Because Yahoo at that time they used to provide 5 MB for each user. Nikita, do you have any queries? Okay. So we used to have 5 MB for Yahoo mailbox. So 5 MB means like after a couple of mails, like 10 mails, if you have it, we need to delete it. Otherwise, we cannot. Like my mailbox is going to be full. So because of that reason, almost we all are migrated at a time into Gmail. So once we are habituated for using Gmail, I think very less people are using Yahoo because of more features and more. Like even Yahoo also providing so many things now, but at the time. So the thing is here, the number of users are more now, and the storage capacity also is more. So now, like in 2004, 1 GB for each user, now 15 GB. You can imagine how many times the storage capacity get increased. 100%, like 15 times, there is no doubt about it. And apart from that, they're like having one account is very tough. But nowadays, each and every person is going to be having more than 2 accounts. This is the one of the main reason. If you talk about the banking domain, see, like most of the people have a wrong interpretation saying that Hadoop means only for like social media. There only we can have huge amount of the data. So if like you are working for like social media, then better to learn Hadoop, otherwise it is not required. It's not like that, guys. Here, see, I have been working with the banking domain almost more than 8 years. Different Macs and different things like even cards, retail and capital market and all. But where, like if you check with that, even the same criteria is going to be applying in the banking system also, guys. There was no online banking previously. Everything is going to be like hard copies. Now everything is in soft copies. So the number of accounts for each and every bank is day by day is increasing it. And the number of features also is increasing it. So obviously their data also is increasing it. So again, to maintain this data and generating the reports dynamically and all, 100% we need to have Hadoop, guys. We can have huge volume of the data. If you check in your area, guys, like the number of banks between like the span of like 10 to 15 years of difference. Before 10 years, how many banks were there in that area? Now, how many banks are there? Lot of difference, guys. So because I have my first account in around 2000, student account in ICICI Bank. I am from Hyderabad. So entire the Hyderabad and Secunderabad, the branches, not ATM centers I'm talking about. At that time, I think 3 branches throughout the Hyderabad and Secunderabad. Now, within the radius of like 1 kilometer distance, I have 3 branches. Because the number of users are increasing. So the day by day the number of users are increasing means obviously the storage capacity also is going to be increasing. Same with the healthcare domain. You can compare with the same thing. The number of hospitals are increasing, the number of people are increasing. They need to maintain. Previously there was no like online system for that. Nowadays, like for each and every patient details, doctor details, like your entire like family details, they are going to be maintaining in that their application. You can simply log in and you can check those reports. So they are maintaining history also. So you are the patient of that hospital from the past like 4 to 5 years. The entire 4 to 5 years history they are going to be maintaining it. In that history, you might be having all the documents like a blood test, like scanning reports or X-rays and all different kinds of the data. Very huge, like some lakhs of patients might be there in a particular hospital, right? So again, they need to maintain those details. There also we can have very huge amount of the data. And another thing is the retail domain, guys. Especially when you're talking about retail domain, I think we can have like from the past like 4 to 5 years. Retail means I think all e-commerce sites, guys. I think Amazon, eBay, Flipkart, Jabaganda, whatever it might be. So where we can have different products, different models, yeah, and all those images and the data. Where we can have huge volume of the data, and the network traffic for that also very huge. Right. So obviously there also we can have huge data, guys. And another thing is the astronomy. Like when you are talking about this photographs, simple photograph I'm talking about, some terabytes of the data it is going to be holding it, guys. Because the resolution is very high. Because they are going to be taking the snaps from some lakhs of kilometers distance, and they are making some enlarge and they are going to showing us. So still the image clarity and all should be good, right? Because of the resolution. So when they want to process those data again, it is very tough. The images, not even video. The image itself only some terabytes of the data. Then another domain is Sensex, where we can have very huge data. Each and every second, all the products data should be logged there. So obviously, per day, some millions of records are going to be updating in their database. And again, they need to maintain the history. Otherwise, how they are going to be getting it? So from the past 3 weeks, this is the minimum and maximum. Okay, past 3 years, this is the minimum and maximum they are going to be giving it, right? So based on what? the historical data. So they need to maintain it. So this is how all the domains, not only a particular domain, all the domains are going to be having huge volume of the data, because day by day it is going to be increasing. Now, what is the problem here? Okay, we came to know how the data is going to be having like huge data in the world. Then what is the problem here? Okay, let me give you the personal, the simple example previously what we discussed it. My mission is having 1 TB hard disk, 8 GB RAM. I am the only one user. So dedicatedly, I am getting 8 GB RAM to process 1 TB data. Okay, the performance is good. There is no issue at all. But when I am making the same laptop or same system as a server, same thing, the hard disk and RAM is same. Server means, I think you know, the concurrent users are going to be accessing at the same time. So when the concurrent users are accessing at the same time here, might be 100 users are going to be processing the same 1 TB data. But the RAM is going to be the same for all the 100 users, right? The RAM is going to be sharing all the 100 users, means each user is going to be getting 80 MB data, 80 MB of RAM. So 80 MB can be possible to process 1 TB data? No ways. It is not at all possible. What need to be done? We need to be increase our RAM. So I'm going to be like, so for me, like the available, maximum available RAM is 128 GB. Might be, it is more than that. Just I'm giving an example. So 128 GB RAM I'm using it. We have to upgrade more than 128 GB. So I have same 100 users. So the 128 GB RAM is going to be sharing across 100 users, means each user is going to be getting 1.28 GB of data. So comparatively it is better, but performance wise little bit slow. But comparatively we can process 1 TB data with 1.8 GB. Right. So now my business is increased down the line, and the number of users are 1000. So each user is going to be getting 128 MB RAM. Again, it is a problem. Like again, it is very tough to process 1 TB data with 128 GB RAM with like 100 users, 1000 users. Then what will be the solution? There is no other alternative to upgrade my RAM. What will be the solution, guys? This is where the problem occurred in our traditional system. Okay, let me give you like a very simple example to have better clarity. Then we'll talk about the legacy system, how it is going to be. Means legacy means the RDBMS. Then we'll talk about Hadoop base. So I'll give you a very simple example. Something, this is the like one. I have some goods or luggage to shift like from one place to another place in my home. So the entire weight is like 100 kilos. I want to shift that. Suppose 100 kilos rice bag I have. I want to shift it from one place to another place. Can I lift 100 kilos? Obviously no. My maximum capacity is okay, 20 to 25 kilos maximum. Beyond that I cannot lift it. What need to be done? So I cannot increase my strength beyond 25 kilos. That is the maximum. But there is a chance of splitting my data into 4 parts, 25, 25, 25 kgs. And I can shift that goods from one place to another place in 4 times. Right. So the thing is, where there is no chance to increase your strength, you can split the source data. Same thing if you observe the previous problem scenario. Instead of increasing the RAM all the time, why can't we split the 1 TB data and split it to multiple across systems? The same thing is happening in our RDBMS case. First, let me talk about RDBMS, because people are habituated for using database as a RDBMS from the past 25 years. More than that even. Then why people are looking forward for Hadoop? Something should be there in this RDBMS. Some like showstopper or some problem is there. So what is that problem? We should know it. So the thing is, the 1 TB data is going to be splitting, right? Each split we used to call it as a data set. As part of RDBMS, each data set capacity is 4 GB. Each data set capacity is 4 GB. So the entire 1 TB data is going to be splitting into number of 4 GBs of data sets. So that means, suppose if you want to be store 10 GB data, it should be storing like 4 plus 4 plus 2, means 3 data sets are required. So our problem is for 1 TB. If I have 1 TB data, 1 TB means 1024 GBs, 1024 by 4 means 256 data sets. So if you want to be store 1 terabyte of the data, RDBMS is going to be holding 256 data sets. So maintaining 256 data sets is okay for RDBMS. There is no, okay, might be, it is possible. But where the data is having like something like 1 petabyte of the data. 1 petabyte means 1024 terabytes of the data. If the data is 1024 terabytes, then how many data sets are required? Okay, if I am simply multiplying with 1000, 256,000 of data sets are required for store the data into your RDBMS case. This is where the problem. RDBMS is not at all capable enough to hold these many data sets. There is a limitation on that. So if it is not able to hold it, how can it process it again? So then people are thinking for alternative. So wherever we have more than terabytes of the data, RDBMS is very tough to process it. So that's why I think, in I think from 2000 onwards, I guess 2008 or 10 approximately, we have a Teradata into the market. What is the purpose of the Teradata? RDBMS is a limitation to process more than terabytes of the data. Then Teradata is the name itself only is mentioned it can support more than terabytes of the data up to maximum. And again, petabytes and more than petabytes of the data, even Teradata also is not going to be helping it out. So instead of increasing the data and supporting it all, so they need to have a permanent solution, and they started implementing this, and which is nothing but a Hadoop base. Hadoop is having the same mechanism. First, let me discuss the solution, then we'll talk about the definition. Here also, we can have the data set, only the concept is common, but each data set capacity is more than terabytes to petabytes of the data. It can hold some terabytes to petabytes of the data in a single data set. That means that if you want to be store 10 GB of data, one data set is enough. 1 TB of data, one data set is enough. Even 1 petabyte of data, single data set is enough to hold it as well as process it. So that means your RDBMS 256,000 of data sets are equal to in your Hadoop a single data set. This is the solution we have in our Hadoop case. Okay. So then we'll move on to the definition. What is Hadoop? I'll give a very simple definition with 4 statements. Hadoop is a framework which will be running in the distributed database for storing and processing the data. When I'm saying storing and processing the data, so many other frameworks are there to store and process the data, like SQL, like Oracle or RDBMS, whatever it might be. Those are frameworks only, which can store the data, which can process the data. What is the big deal with that? The main difference between like your traditional data and your Hadoop is storing big data as well as processing big data. This is the main thing, guys. If there is no big keyword here, Hadoop is not at all required. If it is a normal data, anyone can do that. Got it? So that is the main difference, guys. Now, what is big data? Most of the people might be having a wrong interpretation, saying that like we are learning big data. No, guys, big data is not a technology, big data is not a framework, big data is not a architecture. We are here for learning how to store and process the big data. That's it. Means big data means it has a couple of characteristics. We'll discuss in our regular class those things, but as part of today's session, already we discussed it. Volume, that data size, more than terabytes of the data, wherever we can have, we can call it as big data. There is no fixed measurement, guys. Sometimes it might be 10 GB of data also big. If you are processing with some MBs of RAM, if you are processing 10 GB data, it might be big. The same example, the 100 kilos, I'm going to be like making the partition with 4 and I'm flipping it, right? So 25 kilos is small for everyone. If I ask the same thing for any kid, they cannot lift 25 kilos. For them it is a big again. For me it is not a big. So there is no fixed measurement for that big, guys. but a couple of characteristics are there. So I think as part of like our regular class, we are going to be discussing that. We'll go into more in detail on that class, guys. But as part of time being, big data is nothing but now huge volume of the data. For processing it, Hadoop is required. That's it. Now we'll move on to that point. Like, what is framework, guys? Knowingly, unknowingly, we are using so many frameworks, right? So let me take one example and I'll explain what is framework. Framework means, like, suppose if you want to find maximum salary from your employee table, you'll write a simple query: select maximum of salary from employee table, right? What is this max here? It is a predefined aggregate function. Predefined, that is the important point you should remember. What is mean by this? Someone is already defined it. Defining means the logic, whatever you want to implement for finding the maximum, that logic is developed by some X person and they are going to be sharing with us. We need to use it. Suppose if they are not providing, what you need to do? You need to write a couple of lines of code. You need to take variable, then you need to iterate it, you need to check the condition, you need to assign that value, then you need to return the maximum. And you need to compile it, you need to test it, you need to run it. Those things you need not to bother about it. Someone is already done it. Someone already developed this logic. They developed it, they tested it, they compiled it, everything they have done. They are giving as a component here. They are giving as some already built-in functionality. You should know how to use it. That's it. So that means, what is the advantage you are getting here? So you need not to think about what is the logic you need to implement for finding the maximum. You need not to think about how to test it. You need not to think about whether it is compiled it or not, whether it is going to work for all the scenarios or not. So those things you need not to work. Just simply you can use it and you can run it, case. So that means, where can I run this max? Can I run in a notepad or like command line or like any no, I should run in SQL. What is SQL? It is a framework. So I can define framework like this. Framework is a set of rules. These are the rules which is already defined. That's it. What is the benefit you are getting out of that? Performance, time. So if you want to develop this code and compile it, run it, means half of the day. Like, at least if I am talking about a fresher, as an experienced guy, if you want to implement at least 10 to 15 minutes, you need to waste it, right? So instead of that, within 10 seconds, you can write the max method and you can invoke that. So the performance, the development time is very, very less case here. So in our daily life also, we are using so many frameworks. So many frameworks, knowingly, unknowingly. Right. So the main advantage of framework is some built-in functionality we can have it. By using that, we can develop our applications in a faster way. That's it. So Hadoop also is such kind of framework where it can have so functionalities, the APIs. So we should know how to use those things. Okay. This is what the framework is. Then distribution. When you're talking about distribution, okay, we'll go with again a simple example. What is distribution and all? Most of the people might be knowing it, but what is the advantage? What is the concept behind that? We came to know it now. So when you're talking about distribution here, I'll give you a very simple scenario. I have a task. This is the task, like 1-200 students mark sheets. I have it. I want to go through that all the mark sheets. I need to find out the maximum score out of these 100 students. What need to be done? 1-200 records I need to read one by one, and finally I'll get one output. Some 62nd person having in some 98 marks. So for me, for processing this entire 100 records, it is taking 10 minutes of time. 10 minutes of time. So I want to have the same output less than 3 minutes of time. What need to be done? So instead of I am alone doing this task, I am going to be distributing my task to 4 people. 1 to 25 one person, 26 to 50 another person, 51 to 75, 76 to 100. I am distributing my task to 4 people. So what happens here? So they need not to process 100 records. They can process only 20 records. For 100 records, if it is taking 10 minutes, 25 records, 2.5 minutes, we can complete the task. 2.5 minutes. So the thing is, in this first scenario here, finally the ultimate output we are going to be getting it. But here, 4 people, 4 different set of records they are processing it, 4 different outputs they might be getting it. Means 1 to 25 records, they might be getting 92 as the maximum score. 26 to 50, 89 is the maximum score. 51 to 75, 98 is the maximum. Same way, like 76 to 100, 95 marks is the maximum here. 4 different maximums we can have it. Again, out of these 4, you need to find the ultimate maximum, that is 98 only. The same 62nd person having 98 marks. There is no change in that output. But what is the difference case here? The time. Instead of taking 10 minutes of time, altogether within 3 minutes of time we can get that same output. Why? Because we distributed the task. When you distribute the task, obviously the performance is going to be increasing. The output is not going to change. The same output in a very shorter time we are getting it. What is the secret behind this? Here the data processing is sequentially. First record, second record, third record, and so on till 100 records. But here parallel processing. The first person is reading first record. At the same time, the second person is reading 26th record. At the same time, third person is reading 51st record. At the same time, fourth person is reading 76th record. So here 1 record we completed means here 4 records we completed. Because of parallel processing, the performance is going to be increasing it here. So when you do the distribution, indirectly we are doing the parallel processing. The background mechanism is parallel processing. Hadoop also is distributed and parallel processing mechanism is. Right. So when you see this diagram here, he is like something owner and a slave, and means like master and slave. I can say it's a master and these are like slaves. Master is assigning the task and slaves are doing it. So this entire master and slave configuration, we can call it as a cluster. What is mean by cluster, guys? Cluster is a very simple definition. Some group of machines in a single network. Like here, master, slaves in a single network. Out of that, at least 1 master and more than 1 slave should be there. Then only we can say it's a cluster. Okay, let me give you a very simple example, guys. We are all in a Hadoop classroom, guys. So how can you define this Hadoop class? Some group of people should be in the same network, like here GoToMeeting. Out of that, at least 1 faculty, myself, more than 1 student, yourself. Then we can say it's a class. Otherwise, we are not connected, but we are in front of the laptops at the same time. We are not connected in the GoToMeeting. Can we say it's a class? No. Otherwise, I only logged in. Nobody is joined here. Can I say it's a class? No. Otherwise, only students are logged in. You all are logged in. I am not yet logged in. Can you say it's a class? No, guys. So all the combination should be there. Some group of people should be connected in a single network. At least 1 faculty, more than 1 student should be there. Then only we can say class, right? Same thing we can correlate it here. Some group of missions should be in a single network. At least 1 master should be there. More than 1 slave should be there. So all slaves should interact with the master. Then we can say it's a cluster. That's it. Right? So then Hadoop is going to be running in the clustered environment. When we say distribution, obviously it should be in the clustered environment. So I have a cluster, 1 master and 3 slaves. So if it is having a connection, then only we can say it's a cluster. Otherwise we cannot. So now when I say a cluster, Hadoop is meant for 2 things, storage and processing. Okay, S means storage, P means processing. So if I am saying the storage and processing both in a single layer, what happens? Suppose what I am saying is, in your IT industry, or like any, okay, let me go with 1 simple example. Discuss with this so that like you can have better clarity. So here you want to travel from 1 place to another place, guys. There are 2 paths. One is with the divider. This is the divider. Another one is without divider. Which one you locked and why? Obviously, everybody is going to be looking for this because there is a dedicated path while you are going and a dedicated path while you are coming back. So there are no traffic jams. Within like in time you can reach it. But here, if there is no traffic, you can reach in time. But you are coming and going in the same way, there are chances of having traffic jams. So they might be having some delay. Because coming and going in the two different tasks, you are handling in a single layer. But here, we are handling a different layer. Obviously, the performance is going to be increasing, right? The same mechanism, Hadoop is doing it, guys. The same mechanism, Hadoop is doing it. So Hadoop will come up with a very beautiful solution to handle both storage and processing the cluster to storage and processing in its separate layers. So when it is storing it, it is not going to be impacting on the processing part. When we are processing it, it is not going to be impacting on the storage part. There are two different layers in that Hadoop. Yes. Storage and processing. So when I am talking about storage, if I want to store something, some mechanism should be there. So that mechanism I think is called as HDFS. It is one of the component in Hadoop. HDFS means Hadoop Distributed File System. Hadoop Distributed File System. So when you talk about HDFS here, you can have only the storage mechanism. Only storage mechanism. Same thing for processing also, one more component should be there, right? Which is nothing but MapReduce. MapReduce is for processing. So the thing is here, storage means only HDFS. Processing means only MapReduce. By using HDFS, we cannot process it. By using MapReduce, we cannot store it. This is the thumb rule, guys. You should remember it. So these two things, two layers are heart of Hadoop. If there is no HDFS, there is no MapReduce, there is no Hadoop at all. So my entire cluster should have master side, the storage layer and processing layer, which are nothing but HDFS and MapReduce layer. In the slave side also, HDFS and MapReduce layer should be there. So when my cluster is having storage and processing layers, which are nothing but HDFS and MapReduce layers in both master side and slave side, we can call this as Hadoop cluster. Previously it is a simple cluster. Now we are talking about a Hadoop cluster. What is the difference between that? So let me give you more clarity on that. Suppose I have another mission as part of my cluster, but there is no HDFS and there is no MapReduce. What is the size of cluster, guys? 1, 2, 3, 4 and 5. But what is the size of Hadoop cluster? 1, 2, 3 and 4. I think you can get the difference between cluster and Hadoop cluster. Cluster means master and slave in a single network. That's it. But Hadoop cluster means, first of all, it should be a cluster, and each and every node, both master side and slave side, should have storage and processing layers, which are nothing but here HDFS and MapReduce layers. Then only we can say it is Hadoop cluster. Okay, let us take this node is having HDFS, but there is no MapReduce. Still, we will not count this as part of Hadoop cluster, guys. Both the layers should be there. Then only we can say Hadoop cluster. Okay. Now, coming to this HDFS, I have HDFS in my master side. I have HDFS in slave side. If both are performing the same task, same job, is there any use? Okay, coming to this again, this classroom example. We are all in our class, Hadoop classroom, right? So when I'm saying the class here, those who joined in this GoToMeeting, everybody is having the same role, same task. Is there any use? What I'm saying is, whatever the role I am playing it, same role you are playing, is there any use? No. Otherwise, whatever the role you are playing it, even I am playing the same role, is there any use? Means I am joining here for teaching Hadoop. You joined for learning Hadoop. Even though we are all human beings here, very high level, we have a separate name as a trainer or faculty or a student. Got it, guys? So the same thing here, when we are talking about HDFS, the master side we can have HDFS, slave side we can have HDFS. Both are performing same job, same task. There is no use at all. We should have a separate name, because master HDFS, the role should be different. Slave HDFS, the role should be different. Based on the role, I need to split my HDFS into two parts, guys. I need to split it. Master side HDFS and slave side HDFS. The master side HDFS we can call it as a name node. The slave side HDFS we can call it as a data node. The combination of name node and data node is nothing but HDFS again. The combination of faculty and students are nothing but human beings, right? Same thing. But based on the roles, just we are giving separate name for that. That's it. So my HDFS layer is a name node. My slave HDFS node is nothing but a data node. All the slaves should have the same role. All the slaves, same way. So all the students should have the same roles. Got it, guys? The same mechanism I need to apply for MapReduce also, right? MapReduce is there in master side, MapReduce is there in slave side also. So I want to split my MapReduce into two parts. So my master side MapReduce layer we used to call it as a job tracker. Slave side MapReduce layer we used to call it as a task tracker. So my master side MapReduce layer is a job tracker. Slave side MapReduce layer is a task tracker. The combination of job tracker and task tracker is nothing but a MapReduce. Then we can call it as Hadoop architecture base. The combination of name node, data node, job tracker, task tracker, and one more node we have second name node. Altogether we can say it is a Hadoop architecture. The second name node we are not going to be discussing as part of demo. It will take like minimum 45 minutes to discuss about this, what is second name node and all. As part of our regular class we'll discuss it. So this entire name node, data node, job tracker, task tracker, and second name node we can call it as Hadoop architecture or daemons of Hadoop. What is daemon? Daemon is a background process which will be running continuously. I think in your application, your server, you are deploying your application in the jar or var in one of the server application of web server, right? If you want to run your application, your application, your server need to be up and running. Your server is down, your application also will down. So when you are using your application, nobody is going to be knowing it, what server is doing it, which will be running continuously background of your application. So that is a daemon process. Same way here, why we are calling these as daemons means if you want to run your Hadoop application, these all 5 servers need to be up and running. These are the servers, these are the systems. These servers need to be up and running, guys. This is nothing but Hadoop architecture. Do you have any queries, guys? Technical queries, please let me know. Till now, whatever we discussed it. So otherwise, like I'll take not more than 5 to 10 minutes. We are almost end of the session. So if you don't have any queries, then I'll move forward for the next slide. So there we are going to be discussing about the course. So coming to this course here, couple of things like we are going to be covering both admin and development part, guys. Here, this is moreover admin part, installation, which is hands-on. The course, whatever we are going to be doing here, 100% hands-on that. So we are not going to be installing Hadoop on your machines. You are going to be installing Hadoop on your machines, guys. So we'll discuss about the configuration and all a little bit later. And the prerequisites are you need to have the basic Linux background, you need to have the basic core Java concepts, and the basic SQL. So those who don't have a Linux background, so we are going to be taking 1 or 2 classes for that as part of the course. At the same time, Java, basic Java required. The Java also not for this entire course is around 45 to 50 hours of training, guys. Right. Coming to this Java part, only this module we are going to be working with Java. This is almost 7 hours of topic. Out of the 3 hours are theory part and this 4 hours are practical. These 4 hours we will talk about the Java. Remaining all are non-Java related only. Don't worry about that. The next point is, as part of our course, we are going to be providing 5 to 6 free Java classes. Right. So the thing is, very core Java, not the entire things, entire Java like advanced like servlet JS, PCJBs and the other frameworks we need not to learn. Very core Java, if you know it, that is more than enough. Okay, after that, peak, hive, scoop, HBase, the components we are going to be discussing it. Apart from that, around 40 plus components we have, guys. Nobody is going to be having idea about all these components. Then Spark and Scala also we have. Altogether, this is a separate course. It is like again 45 hours we need to talk about it if it is Spark and Scala. So each and every component like this, like keep on increasing, like minimum 3 to 5 to 7 hours of concepts. So as part of our course, we are going to be covering peak, hive, scoop, HBase, and followed by Hadoop 1.x and Hadoop 2.x. The comparisons, the architectures we are going to be discussing. So all those things hands-on, guys. See the big installation, configuration, setup. Same way hive, scoop, HBase. Yeah, end to end, you are going to be doing it in hands-on only. And as part of our course, I think 30% of classes might be theory, 70% of the classes are practical oriented case. 70% of the classes are practical oriented. Each and every example, we are going to be writing a code, each and every concept, we are executing it. So with examples only, we are going to be discussing the concepts case, more or hands-on. Because I am not going to be concentrating much on theory, because if you spend like half an hour in the Google, you can have a lot of theory. Whatever I am sharing it, you can get more than that. So anybody can get the theory from Google, but the practical you may not get it. So those things we are going to be covering it here. Within this 45 to 50 hours of training, 100% of the Hadoop we are not going to be covering. Even myself, I don't know 100% of the Hadoop. And after completion of this course, you'll be comfortable to do all the hands-on. You can install Hadoop on your own. You can do practicals on your own. That much comfortable level we can provide it. So how much knowledge the 2 years experience game might be having in the real time, right? That much knowledge you might be getting it. That's it. Right? So it is like a ocean. Nobody knows. See, myself, I know only 25% of the Hadoop. Might be I am teaching only around 20% of the Hadoop out of that. 15 to 20% might be. So you might be getting only 10%. So after completion of that course, entire Hadoop, you might be having 10% of the knowledge. That's it. It's a version. Again, day by day, if you are doing something, even still, if I am as part of my project, again, we need to struggle for some functionalities in the Hadoop. We need to go through the API. We need to Google it. We need to struggle it. So once we resolve that, we are knowing some new concept on that day. And day by day, we are learning it. So that's what I'm saying. Even Java, more than 10 years of experience I have. Might be 25 to 30% of the Java I might be knowing it. That's it. Right. Same thing. Here you might be comfortable after completion of this course to have hands on that. That much guarantee we are going to provide it, guys. After that, we are going to be providing the project explanation. We are not going to be sharing any code or any project, because the live project, the architecture and the scenarios we are going to be discussing it, guys. I will not show any single line of the code on that. End to end, the project from the getting the requirements to till the production. What are the things that to be done there? Here in the POC point of view, will make you to do the coding. We will share the code, the sample project, right? And will help you to prepare your resume. We'll share the FAQs on daily basis in the class itself only, and we have some terms and we'll share across with you. The softwares and materials we are going to be mailing across, right? Okay, this is the basic things we are going to be covering as part of our course, guys. Right? So please let me know if you have any queries then.
I have a question. You mentioned we would be installing the Hadoop by ourselves.
Yes.
Would you be installing in the local system, or you guys would be providing a VMware?
In your local system, we'll install VMware first. On top of that, we'll install Hadoop. So we will make you to do the installation, guys. So we'll provide all the softwares, we'll provide all the steps, and step by step will execute one of your machine, and that machine will be sharing across to you all, and one command you can run from your machine. This is how we can do that.
Okay. And you mentioned about the hands-on, the practical side of it.
Yes, yes.
So will it be kind of a real-time, use cases? Because I have seen some videos in the internet, YouTube, and the example they provide is mostly like word count, which is, I don't know how much it will be useful in a project we're working for a client.
Yes, yes. Yeah, as part of our course, the word count is nothing but a very basic hello world program kind of thing in Hadoop MapReduce point of view. Apart from that, we are going to be discussing 3 to 4 scenarios. Different joins we'll do that, and some weather analysis we'll do that, and some other scenarios, some partitioning mechanism. Each and every concept will execute one program in real time, which will be helpful. And again, I'm saying that's what I'm mentioning it, right? If you learn even 1 year the course, something is missing it. As in your real time, whatever you are doing of this 10 years, it might not be helpful for in your new project what you moved in the same technology, right? There again you need to do some R&D to. So same kind of thing. So the course is going to be helping you to, so if you have any new scenario, how to address it, how to debug it, and how to search it, and how to implement that new functionality by your own. That much knowledge you can get it.
Okay. Okay, got that.
Yep.
Thank you.